Welcome to the new podcast series by Kuraray Europe and its brands for high-tech glass interlayer solutions Trosifol and Glass. With this podcast, we aim to give you practical knowledge and inspiration on all aspects of glass and architecture. What new design possibilities do laminated safety glass solutions offer? And how can our innovative interlayer solutions help improve the acoustics and climate in buildings? With experts from Kuraray, we tackle current topics, both practically and in dialogue. We hope you enjoy this episode and get inspired.
Welcome to a new podcast episode. My name is Björn Sanden and I'm a high-performance product specialist at Kuraray. Today we're going to talk about noise and how glazing solutions with Kuraray interlayers can eliminate disturbing sounds and create perfect acoustics in buildings. For this topic, I've invited Alan Gibson, our high-performance product manager for Northern Europe at Kuraray. Thanks, Alan, for being here today.
Thanks, Bjorn. It's a pleasure. Thanks for having me.
So, Alan, regularly I'm walking around in cities like Frankfurt, London, and Berlin, and noise levels on the streets seem to have been increasing from year to year.
You're absolutely right, Bjorn, and you obviously get around quite a lot. And it's not just your perception. Noise pollution in our cities is increasing and has already reached a very high level. The Department for Environment, Food and Rural Affairs has published a very interesting study on noise pollution in London. Almost 40% of Londoners are constantly exposed to noise above the 54 decibel threshold that they've set, and above the value from which the World Health Organization classifies noise pollution as harmful to health. London is just one example, but there are similar results from cities throughout the world, and experts assume that this trend will only get worse.
So that's interesting. But why is it that people believe that these noise trends are going to continue to increase?
Well, the main reason, more and more people are living in cities now. In fact, the United Nations predict that in 2050, 68% of the world's population will actually be residing in cities. With more people, there is the need for more mobility. And as this increases, even if we drive these supposedly quieter electric cars in the future, the actual overall noise will increase.
Yeah, and noise is not really a nice thing for the human ear. It's in fact, I can believe it's harmful to health. You mentioned about the World Health Organization guidelines, which have set a maximum noise level of 54 decibels. What are the consequences of permanent exposures to noise above these values?
Well, in short, noise can make you poorly. In psychology and psychoacoustics, the reaction of the sound waves by the ear and how they're perceived by the brain, noise is unwanted sound. And it can cause cardiovascular disease, annoyance, cognitive impairment, hearing impairment, tinnitus, and these are just a few examples. Now, it comes as an incredible cost to our healthcare systems and economies. And the non-profit organisation RAND in Europe, they estimate the cost of sleep deprivation alone from noise pollution is around £40 billion each year. And that's just in the UK. Employees are less productive and they take more sick leave. And I think that's a pretty good reason why building operators in cities should have an invested interest in creating a better noise control, better acoustic performance within their buildings.
Yeah, you're right. And I guess we have to take this in account when we're planning buildings effectively to protect users and residents from noise, right?
Exactly, Bjorn. And to explain this better, it's important to understand some basic things about noise. Physically, noise is nothing more than a mechanical wave. But sound can take different forms, which also has an impact on the design of noise protection. For example, we have to differentiate between the higher sound noises and the lower sound noises. And the pitch of this sound, how the high or the low sound, it depends on the amount of waves that pass per second, and these are expressed as hertz. Now we can only perceive a comparably narrow range of frequencies at any time. The human ear can hear sound between 20 hertz and 20,000 hertz. But bats can hear ultrasonic frequencies from 2000 hertz to 120,000 hertz.
Yes, those are I've heard about the hertz, but I hear often also about decibels. So is that also referring to how loud something is?
Exactly. You're totally right, Bjorn. A decibel is the unit for sound pressure. And to give you an overview, human speech is around about 60 decibels. Loud rock music, 110 decibels. But the loudest you can hear without damaging your ears is around about 120 decibels. Now the key figure also indicates how strong the noise pollution is. So coming to your question, when planning a building, the first thing we have to consider is how strong the noise pollution in a building is, both inside and out. In a building, noise can come from the outside, for example, the street via direct airborne transmitted noises, or from other rooms vertically and horizontal, and this is actually called flanking.
Okay, Alan, I understand that part. So to minimize this kind of noise pollution, what are the requirements that you put on glazing to be able to do this effectively?
Well, this is probably best explained, Bjorn, with an example. Glazed partitions are often used, especially in offices, and the performance of these partitions can be measured either in a laboratory or they could be measured on site. And the weighted value, the RW or the DW, is decisive for this. It shows by how much the volume has been reduced. Now, in order to make a conversation from one office to another office unintelligible, we use glazed partitions. The minimum sound insulation needs to be around about 38 decibels. Now, in some applications, they may require extra privacy. For example, in a bank or a hospital, and they may require even greater sound insulation of 48 decibels, and that can be quite a challenge.
Yeah, I can imagine that. 48 decibels, that's high. So how do you achieve such high sound insulation values in glass?
Well, one way to overcome this challenge is to use thicker glass panels or introduce mass, or to use 2 layers of glass and maybe put some air insulation between them, like you would in your home with a double glazed unit. However, for many applications, thick glass panes, they're just not technically possible. Thick panes of glass are very heavy, they're bulky and cumbersome, and do not often give the lightness of the modern architecture that they're being put into. Now, we could introduce a Trosifol sound control interlayer, which would offer a very simple and effective solution.
Yeah, Trosifol sound control interlayer. What makes them so special versus other types of interlayer?
Well, like all of our interlayers, Kuraray create a very high performance laminated safety glass solutions, and it ensures more safety if a pane of glass breaks, to ensure that all the glass shards, all the very sharp shards of glass stick to the interlayer and don't injure anybody. And it has excellent properties in terms of long-term stability and light fastness and optics and so on. But the special thing about Trosifol sound control is its outstanding acoustic performance. Now, it can reduce noise significantly by up to 53 decibels. Now, for different applications that have different requirements, we offer our acoustic interlayers in both a mono layer and also a multi-layer.
Okay, monolayer, multi-layer. Do they differ in terms of performance?
Well, both options are very good in terms of insulating properties. Our monolayer solution is slightly softer and is ideal for normal glazing, for example, office partitions, and for more technically demanding glazing, such as roof or curtain glazing, our multi-layer solution may be the better choice. The multi-layer solution can be flexibly combined with standard and coloured films, and this offers even more options for the building design. But both products meet the guidance of EN 356 and EN 12600 for security and for safety glasses.
Yes, that's important information, Alan. And compared to monolithic glazing, you have a more safe glazing because it's laminated, but also now it has acoustic performance, right?
Yeah, that's right, Bjorn. And that offers another advantage. With laminated solutions, we can produce much thinner glazing with excellent sound insulation. Now, for instance, a 10mm thick monolithic sliding glass panel offers an acoustic insulation value of around about 33 decibels. In comparison, laminated glazing made of two 5mm panes of glass and a standard PVB film already offers an insulation value of 35 decibels. But if we include a Trosifol sound control interlayer, we can achieve a sound insulation of 38 decibels with exactly the same structure. So even if we slim down the two panes of glass to 3mm each, we still get an excellent insulation value of 36 decibels with Trosifol sound control. Laminates also significantly reduce the coincidence dip compared to monolithic glazing.
Coincidence dip. Can you explain?
Yeah, the coincidence dip is when the frequency of the glass panel vibrates at the same frequency as the sound pressure wave. So as the sound hits the glass will start to vibrate, and if the sound pressure wave and the glass vibrate at the same time, then at that time the sound insulation properties are significantly reduced. So the formula to calculate the coincidence dip frequencies is 12,500 divided by the thickness of the glass panel, but that's immaterial. The most important thing is that the thickness of the glass affects the coincidence dip.
And an acoustic interlayer helps dampen this effect, right?
That's correct. And the Trosifol sound control, we can improve this noise reduction significantly by up to 10 decibels, especially in common frequencies between 630 and 2500 hertz.
Do you have maybe some examples where Trosifol acoustic interlayers has been used?
Absolutely. In fact, one of my favourite projects is the Pier House, and this is in New York City. And the Pier House is part of a recently transformed Brooklyn Heights waterfront. As a luxury housing project, it contains a selection of residences from 1 to 5 bedrooms, and believe me, they do not come cheap.
And given the location, I assume the building also offers some other architectural advantages and challenges.
Exactly. Well, when you're paying a lot of money for a condo in such a great location, it's precisely the importance of the high acoustic demands of the glazing. Now, the building has two primary faces. One that mirrors the traditional brownstone looks of the prevalent with the Brooklyn area, and the other side with its significant glazed area, which gives every resident an unparalleled view of the New York Harbour and the park. Now, for the units facing the East River and the Brooklyn Bridge Park, noise comes from the park activities, including live music performances, as well as helicopters flying to and from Lower Manhattan. And on the Brooklyn side, the planners had to contend with the Brooklyn Railway traffic noise and also the industrial noise coming from the Brooklyn neighborhood.
And from a noise perspective, I guess this is a pretty demanding project, right?
Yeah, that's right. And that's why the architects and planners opted for a monolayer acoustic film. With Trosifol sound control, the building has a glazing with excellent insulation performance. The residents can enjoy their home in the best location without any disturbing noises from the outside. And by the way, our interlayers were also used in numerous airport projects.
At airports, interesting. I would guess that these are among the most demanding applications when it gets to sound insulation.
Exactly. And that's why the glazed roof at the new gallery at the Marco Polo Airport in Venice, our interlayers were the first choice. And another recent example was the Pinto Martins International Airport at Fortaleza in Brazil.
Well, this is fantastic to hear about what Trosifol interlayers can do in the field of acoustics. They have already proven themselves worthy for many projects. So tell me, Alan, how do we support our customers and specifiers when it comes to choosing the right solution?
Well, on one hand, we have our services team that offer a comprehensive advice, and that can either be on the phone or person to person, or through Teams. But we also offer various free-to-use calculation tools on our website, and they can be downloaded on the phone or used on the PC. For example, we have the Trosifol Glass Global, and this is an excellent tool for calculating static loads. And we also have the Trosifol Win SLT, and this would be used to calculate the light and the solar energy transmission. And for acoustics, which is predominantly what this podcast is about, we have two fantastic applications. We have SoundLab and SoundLab AI. Definitely the right choice.
Okay, that sounds interesting. Can you tell me more about this SoundLab app?
Of course. Well, the SoundLab app, users can calculate what glazing options they have or what they would need to create perfect acoustic performances for their project. Users can enter various parameters within the app, for example, the desired glass structure, the thickness of the glass, the desired installation performance, whether it be dBRW or for European norms, or STC and OITC for the US. And after the calculation, the customers simply receive a result in the report and a test report to substantiate the fact, and this can be sent directly to their email address.
Wow, that sounds like a very helpful tool for our customers and specifiers, Alan. However, we're almost at the end of today's podcast episode. Just one more question before we wrap up today. Where can I and the listener find more information about the different solutions for sound control by Trosifol and Sentry Glass?
Well, our website has an extensive range of products and brochures. So all our products are supported with brochures and all the technical data that would be required to help you do the specification. We also have a really great selection of customer case studies, so you can see projects and understand more about what was used in them. There's really too much to list, but I certainly recommend that they go onto the website and have a look. And as well as that, there's ourselves. There's myself and yourself, and we're happy to take any questions and deal with any queries. So all I ask is that you pick up the phone and give us a call.
Okay. Well, Alan, thank you very much for this really interesting discussion and the useful information you shared with us.
You're very welcome. Thank you for having me.
Thanks for listening. We hope you found this podcast useful and that you now know more about the innovative interlayer solutions that Trosifol and Sentry Glass offer you for your architectural and engineering projects. For more information, please contact our technical service or look at our website at trosifol.com. And don't forget to tune in again next time for more information on Kuraray's glass interlayer brands Trosifol and Sentry Glass. See you then.